we have yet another equation here, which is for the exponential distribution. So the parameter here is theta. How can we find the sufficient statistics for the parameter theta? This is the distribution. What we need to do is just to factor this out, to factor the distribution. For we to factor the distribution, we just take the products. So when taking this, we get something like this. F x1 x2 to xn. The parameter is theta will be equal to 1 all over theta. We get 1 all over theta exponential minus x1 theta multiplied by 1 all over theta exponential x2 theta multiplied by, it continues to give 1 all over theta exponential xi all over theta. If we bring all of these together, we get something like this. F x1 x2 xn, the parameter to be equal to 1 all over theta. Since it's a constant, there will be n here. Then exponential negative. If we sum this, we get summation xi all over theta. Writing this thing well, we can put it in this way. 1 all over theta exponential negative solution xi all over theta. So what we need to do is to see how we can get the two components, just as the factorization theory stated, how we can get the two components for this. So for we to get the two components, we move over to this side. We write out the function first, x1, x2 to xn theta to give us 1 all over theta n exponential summation of xi all over theta. Here I is running from 1 to n multiplied by 1. The whole of this function now becomes our phi mu x1 x2 to xn. Our theta is, then this one becomes this other components x1 x2 and xn to xn. This can also be written in this form, mu to the summation of xi, and you put down a parameter, and h to give this. So since we have these two components, it is good to say that the summation of xi is a sufficient statistics. Sufficient statistics for theta, since theta is the parameter given in the equation. So this is how to resolve the exponential distribution for the factorization theorem.